Okay, so when we're talking about mathematical functions, we often want to visualize what these look like. And one of my students many years ago, when I drew one of these diagrams, christened it as a potato diagram. So that's what I've called them ever since. So I've told you already that a mathematical function is a mapping from one set to another. So let's have some sets here. Let's have the set of the numbers 1, 2, 3 and 4. So here is the numbers 1, 2, 3 and 4, and that's my input set, and my input set is called the domain. Then I have my output set. Let's have the numbers 0 and 1 here. This is my output set, which is called the codomain. That's all the possible outputs that we could have for this particular function. So these two are sets. And then what we do to create a potato diagram is that we wire it up according to some function that we've been specified. Let's say we've got a function f of n is specified as follows. Well, it's a set of pairs. Let's say that 1 maps on to 0, 2 maps on to 1, 3 maps on to 0, and 4 maps on to 1. Great, so let's actually draw this function. Use a different colour for this. So 1 maps onto 0, so that goes like that. 2, that maps onto 1. 3 maps onto 0, that's fine. And 4 maps onto 1. So that's the full potato diagram for this particular function. Let's call it f1 because I'm going to do a different function now for you. So let's take a second function. Okay, so this is the domain. This full set is called the codomain, and the set of all values that get pointed to, that's called the range, or sometimes also called the image, but I'm going to call it the range. So for this function, the domain is the set 1, 2, 3 and 4. That's the set that is the domain. The codomain is equal to the set 0 and 1, and I'll move this up just a little bit so you can see it. Oops, there's my wire falling down. Got a lot of wires here, there we go. And the range, that's also equal to the set 0 and 1. Now, if I had a function where everything mapped onto 0, that's a perfectly decent function. In fact, let me draw that function for you. The function where everything maps onto 0. I'll get another bit of the paper here. There we go. So let's have a potato diagram. We'll have the same domain and the same codomain. So we'll have 1, 2, 3 and 4 for the domain, and 0 and 1 for the codomain. Only this time f of n is defined like this. It is the set of pairs such that 1 maps onto 0, 2 maps onto 0, 3 maps onto 0, and you've guessed it, 4 maps onto 0. That's a good curly bracket. I like that one. That's a perfectly decent function because for each and every member of the input set, there is one and only one member of the output set. It doesn't matter that I haven't used up one here. So I'll draw this function for you. There's 1, 2, 3, and 4. So that's the potato diagram for that function. So the domain is equal to the set 1, 2, 3, and 4. The codomain is equal to the set 0 and 1. That's the range of possible values for this function. But the range set, that just has the value 0. So there's only one element in the range set for this particular function. And that tells you everything that you need to know about potato diagrams. And I'm indebted to my student Emma, who first introduced me to that term.